Good morning, students. Today also we will discuss few more problems on this chapter. This question asked in this year 2020 regular, right? So the first one, 3 resistors, 3 ohm, 4 ohm, 1 ohm are connected in parallel. What is effective resistance? What is effective resistance for combination? So in the second one, if the combination is connected to a battery, of EMF 6 ohm and internal resistance 0.5 ohm. Internal resistance 0.5. Find the current drawn from the battery and terminal potential difference across the battery. So similar example we discussed in series. So here in this year in regular they ask this question for in parallel combination, right? So they given 3 resistance, 3 ohm, 4 ohm and 12 ohm are connected in parallel. So what is the effective resistance of the combination? That means first we need to find the equivalent resistance, right? So for that we need to draw the 3 resistors which are connected in parallel, right? So naming this one as R1 3 ohm, R2 4 ohm, and R3 1 ohm. Right? So the effective resistance of the combination, right? So we know the formula for the equivalent resistance, which are the 3 connected in parallel, that is 1 by Rp, that is equals to 1 by R1 plus 1 by R2 plus 1 by R3, right? So here we know the values for each resistance, 1 by 3 plus 1 by 4 plus 1 by 12. So LCM becomes 12. So 3 4s are 12, 4 3s are 12, plus 12 ones are 12, right? So 1 by Rp. So this gives 4 plus 3 7 plus 1, that is 8 divided by 12. So 4 2s are 8, 4 3s are 12. So it is in the reciprocal. So it becomes Rp is equals to 3 by 2 ohm, or Rp is equals to 1.5 ohm. So this is the solution for the first question, right? So next, the same combination is connected to the battery of EMF 6 volt, right? So the 3 resistances which are connected in parallel. So this combination they connected to the battery of EMF 6 volt and it has the internal resistance 0.5. So here we need to find the current drawn from the battery and the terminal potential difference across the battery. Either we can join here with an voltage of 6 volt, or we can directly by drawing the equivalent resistance. So this becomes Rp, that is equals to 1.5 ohm. So here 6 volt internal resistance 0.5 ohm. We need to find the current flowing in the circuit I. Right? So now ಇಲ್ಲಿ ಬ್ಯಾಟರಿ ನಾವು ಕನೆಕ್ಟ್ ಮಾಡಬಹುದು or directly we can take here the equivalent resistance Rp. Right? So we know the formula to find the current when the cell having the internal resistance 0.5 ohm, that is I is equals to E divided by R plus small r, where R is the external resistance. So here that is the combination of three resistance, right? Small r is the internal resistance and EMF is 6 volt, right? That is 6 divided by RP is 1.5 plus 0.5. 6 divided by 2, the current flowing in the circuit I is 3 amperes, right? So next, the potential difference across the battery. So potential difference across the battery is we need to find the potential difference across this resistance Rp, right? Or we have the formula V is equals to E minus IR, where V is the potential difference across the battery or across this resistance, right? So either we can multiply I into Rp or by using this formula, right? So V is equals to E is how much they given? 6 minus I is 3 into Rp is 1.5, right? So 6 minus 4.5, so we get 1.5 volts. So this gives what? The terminal potential difference, right? So this is the formula V is equals to E minus IR, right? So question. So same problem is solved in series. So once they ask this in parallel combination, right? When two resistors are connected in series with a cell of EMF 2 volt and negligible internal resistance and negligible internal resistance, negligible internal resistance, a current of 2 by 5 ampere flows in the circuit, flows in the circuit. When the resistors are connected, when the resistors are connected in parallel, when the resistors are connected in parallel, the main current is 5 by 3 amperes calculate the resistance. So in this question they given two unknown resistance. In the first case they connected in series. So those two resistance are connected with an external source, that is the EMF having 2 volt and negligible internal resistance. That means small r is equals to 0, right? So the current flowing in the circuit, that is the current flowing in the series, they given 2 by 5 amperes, right? So next the same two resistance are connected in parallel. Next the main current in that circuit flowing is 5 by 3 ampere and the same EMF is connected to. Now we need to find the individual resistances R1 and R2. Right? So in the first case we don't know the two resistance. So taken those two resistances as R1 and R2, and these two resistances are connected in series and with the external source of EMF 2 volt and internal resistance is 0. That means small r is 0 and they given the current flowing in the circuit is 2 by 5 amperes. Right? So from this we can find R1, R2. That is when two resistances are in series, they given the current and they given the voltage. We need to find the individual resistances R1 and R2. Right? So from the Ohm's law, V is equals to I RS, where RS resistances which are connected in series. So they given 2 volts, that is equals to current they given 2 divided by 5. The formula for the resistances which are connected in series, that is RS is equals to R1 plus R2. Right? So two resistances which are connected. So here in the numerator 2, in the LHS we have 2 get cancels. So we get R1 plus R2, that is equals to 5. Calling this one as equation 1. So this is from the first case. Now the same two resistances which are connected in parallel. So these two combination is connected to same 2 volt battery, the same two resistance. That's why we take an R1 and R2. And now the current flowing in the circuit, main circuit is they given 5 by 3 amperes. Right? So again from the Ohm's law we have the relation V is equals to I. Here the two resistances are connected in parallel, hence we take an RP. So we know the relation RP for the two resistance, that is R1, R2 divided by R1 plus R2. That is 1 by RP is equals to 1 by R1 plus 1 by R2. Thus we can write RP is equals to R1, R2 divided by R1 plus R2. So here we know the voltage 2 and also we know the current, that is 5 by 3. And in place of RP we can write R1, R2 divided by R1 plus R2. Right? So now 2 as it is 5 divided by 3 R1 R2 divided by, so in place of R1 and R2, R1 plus R2, we have the value 5. So substituting here R1 plus R2, that is equals to 5. So that is from first equation. Right? So here in the numerator and the denominator 5 get cancelled. So R1, R2, that is equals to 6. That is 3 into 2, that is equals to 6. Calling this one as second equation. Right? Now, to find R1 and R2, we need an equation. That is two equations. So for that, R1 minus R2 whole square, we write this one as R1 plus R2 whole square minus 4 R1 R2. The same relation we used in the capacitors also. To find the individual capacitance, C1 minus C2 whole square, that is equals to C1 plus C2 whole square minus 4 C1 C2. So ಇದನ್ನ simplify ಮಾಡಿದ್ರೆ finally we get R1 minus R2 whole square. Right? So R1 plus R2, we know the value, that is 5 square minus 4 into R1 R2, we know the value, that is 6. Right? So 25 minus 24, that is equals to 1. R1 minus 2 individual resistance, R1 and so the given condition when two resistors are connected in series, the current flowing is 2 by 5 amperes, and in parallel the current flowing is 5 by 3 amperes. So both the combination is connected to the same EMF, right? So very important. So ಇದನ್ನು ಕೂಡ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಕೇಳಿದ್ದಾರೆ. So next, two resistors, 3 ohm and 6 ohm are connected in parallel, to a cell of EMF, to a cell of EMF 1.5 volt and internal resistance 1 ohm. Find the current in various branches and also in the circuit. So all these questions they are asked in the examination, right? So here is given two resistors 3 ohm and 6 ohm are connected in parallel to a cell of EMF 1.5 volt and internal resistance 1 ohm. So simple problem is that. So they given two resistors. So these two resistances are connected in parallel, right? So one is, that is R1 is equals to 3 ohm and R2 is equals to 6 ohm, right? So these two resistances which is connected across the battery of EMF 1.5 volt and they have the internal resistance they given 1 ohm, right? So here we need to find the current flowing in each branch, that is I1 and I2 and the total current I. So if we take a junction this as A and B, so at this junction the current divides, the total current divides into two branches. So one is I1 and another one is I2, right? So before going to find the branch current, first we need to find the total current, right? So for the total current, first we need to simplify this two resistance into equivalent resistance, right? So as these two resistances are in parallel, so 1 by Rp that is equals to 1 by R1 plus 1 by R2. Effective resistance formula, that is 1 by Rp is equals to 1 by R1 plus 1 by R2. So 1 by R1 is 3 plus 1 by R2 is 1 by 6. So LCM is 6, 2 plus 1. So 3 divided by 6, that is 1 by 2, 1 by Rp, right? So Rp is equals to 2 ohm, right? So effective resistance is 2 ohm. So now we can write this one as single resistance. This Rp is equals to 2 ohm. So here they connected 1.5 volt and 1 ohm resistance. So current flowing through the circuit is I. So first we need to find the current in the circuit. So ಇಲ್ಲಿ I ಮತ್ತು ಇಲ್ಲಿ ಎರಡು ಸೇಮ್ ಇದೆ. We written this in the form of single resistance, right? So I is equals to E divided by Rp plus R. So where E is the EMF and Rp is the external resistance and small r is the internal resistance, right? So E is 1.5, Rp is 2 plus 1. Internal resistance is 1, right? So we can write this is 1.5 divided by 3. So the total current is 0.5 amperes. So now get total current into 0.5 amperes which is flowing in the circuit. Now we need to find the branch currents I1 and I2. So as these two are connected in parallel, so ಇಲ್ಲಿ ನಮಗೆ ಏನು ವೋಲ್ಟೇಜ್ ಇರುತ್ತೋ across this has the same voltage and the same voltage is across this cell. So first we need to find the voltage across this cell, right? So across this cell, the formula to find the voltage, that is V is equals to E minus IR, right? Where I is the total current which is flowing in the circuit and R is the internal resistance, right? So from this we can find the voltage that is across the cell, right? So E is 1.5 minus I is 0.5 and internal resistance is 1. So 1.5 minus 0.5, so we get 1 volt. So this 1 volt is same across the 3 ohm resistance and also 6 ohm resistance. So from the we can find I1 and I2, right? So here we have 1 volt. So same here also we have 1 volt, right? So from Ohm's law, V is equals to IR. So here we are going to find I1. So V is equals to I1 R1. So I1 is equals to V divided by R1. V is 1 divided by R1 is 3, right? So the current I1 that is equals to 0.33 amperes, right? So this is the branch current I1, right? So in the same way I2 is equals to V divided by R2, that is equals to 1 divided by 6, right? So 0.6 ones are 6, so remaining 4, so we get 1.66 amperes. This is what we get, that is I2. So these are the two branch currents I1 and I2, or we can find I2 by, that is I is equals to I1 plus I2. As already we know I, that is 0.5, and we find the value 0.33 plus I2, then I2 is equals to 0.5 minus 0.33, right? 7, so 0.17 ampere. Either we can use Kirchhoff current law or directly we use Ohm's law. I is equals to V divided by R. We getting the same, that is 1.6 and so on, approximately equals to 1.7. That we are getting, right? So in case if they won't give any internal resistance in the exam, so namge internal resistance 1 kodilla andre the potential across the cell is 1.5 volt. So it means the resistance, that is voltage across 6 ohm resistance is 1. And 3 ohm resistance also 1.5 volt. So ಇದನ್ನ ನಾವು ಕೇರ್ಫುಲ್ ಆಗಿ ಅಬ್ಸರ್ವ್ ಮಾಡಬೇಕು. So internal resistance ಕೊಟ್ಟರು ಅಂದ್ರೆ ನಾವು ಈ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡ್ಕೋಬೇಕು. V is equals to E minus IR. So if they won't give any internal resistance, that means R value is 0. That means V is equals to E. So ನಮಗೆ ಇಲ್ಲಿ ಏನು initially voltage ಕೊಟ್ಟಿರ್ತಾರೋ the same voltage will be across 6 ohm resistance and also across 3 ohm resistance. So ಇದು ಕೇರ್ಫುಲ್ ಆಗಿ ಅಬ್ಸರ್ವ್ ಮಾಡಬೇಕು. So direct now 1. In case they given 1 ohm as internal resistance, directly if I take here 1.5 volt, then we get the wrong answers, right? So after getting the answer sum ಮಾಡಿದ್ರೆ ನಮಗೆ I value 0.5 amperes ಬರಬೇಕು. So ಇಲ್ಲಿ 1.5 volt ತಗೊಂಡ್ರೆ ನಮಗೆ values change ಆಗುತ್ತೆ. Then the total current will be greater than we are getting 0.5, right? So ಇದು careful ಆಗಿ ಅಬ್ಸರ್ವ್ ಮಾಡಬೇಕು. Internal resistance, right? So next step, a battery of internal resistance, a battery of internal resistance, battery of internal resistance 3 ohm is connected, 3 ohm is connected to 20 ohm resistance to the same, and potential difference across the resistor is 10 volt. If another resistor 30 ohm is connected in series, with the first resistor, and battery is again connected to the combination, battery is again connected to the combination. Calculate the EMF and terminal potential difference, across the combination. So this problem is on the cell, right? That is battery. So a battery of internal resistance, that means cell of internal resistance 3 ohm is connected to the 20 ohm resistor, and the potential difference across the resistor is 10 volt. That means one battery is there, right? So this battery having the internal resistance 3 ohm, right? So now this battery is connected to the external resistance of 20 ohm. So ಈ ಬ್ಯಾಟರಿನ ಏನು ಮಾಡ್ತಾ ಇದ್ದಾರೆ, ಒಂದು external resistance ಗೆ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ದಾರೆ, right? So that resistance, that is 20 ohm, right? So now the given potential difference across the resistor is 10 volt. That means the potential difference across the resistance are the given, that is 10 volt, right? So this is the first case. Next, if the another resistor 30 ohm is connected in series with the first resistor, so the same only the given 10 volt, right? So further they are added a 30 ohm resistor in series with the 20 ohm resistor. So we need to find the total potential difference between A and B. That is, we need to find the V. So right, so this V is equals to the potential that is across the cell. So ನಮಗೆ across this two resistance ಅಲ್ಲಿ ಏನು voltage ಇದೆ, the same voltage will be across this resistor, right? So from Ohm's law, so ಇಲ್ಲಿ ನಮಗೆ current is unknown. First we need to find the current, then easily we get the EMF of the cell. So the formula is V is equals to E minus IR, right? So or yes. So from the 10 volt across this resistance is same as 10 volt across this cell. So ಇಲ್ಲಿ 10 volt ಇದೆ, as these two are in parallel. So ಇಲ್ಲಿ 10 volt ಇದೆ, ಇಲ್ಲಿ ಕೂಡ ಏನಿರುತ್ತೆ ನಮಗೆ same 10 volt ಇರುತ್ತೆ, right? So but E is unknown and we know the internal resistance. So I is unknown. So ಇಲ್ಲಿ ಎರಡು unknown ಇರೋದ್ರಿಂದ first we need to find the current I, that is from the Ohm's law. So current flowing across this resistor, we know the resistance and also we know the voltage. V is equals to IR. So R ಗೊತ್ತಿದೆ, V ಗೊತ್ತಿದೆ. Easily we can find the current flowing in the circuit I, right? So that is I is equals to V divided by R. So V 10 volt divided by resistance is 20. That is 1 by 2. So the current flowing is 0.5 amperes. Right, so ಇಲ್ಲಿ current flow ಆಗ್ತಾ ಇರೋದು ಎಷ್ಟಿದೆ 0.5 amperes. Now V is equals to E minus IR, right? So V ಗೊತ್ತಿದೆ, now I ಗೊತ್ತಿದೆ, R ಗೊತ್ತಿದೆ, we can easily find E. So V is 10, that is equals to E minus current 1 by 2 or 0.5. So 1 by 2 or 0.5. So internal resistance 3, right? So 10, that is equals to E minus 1.5. So this minus 1.5, if it shifts to RHS, it becomes plus 1.5. Then EMF of a cell is 11.5 volt. So this is first case. So first we find out the EMF of a cell. So that gives what 11.5. So same battery is connected here also. That means the value of E is 11.5 volts. So here we need to find the terminal potential difference across this combination. As these two are in series, then the effective resistance is R1 plus R2. So R1 is 20 ohm, R2 is 30 ohm. So that gives what 50 ohm. So this is the combination of two resistors. So now we need to find the potential difference across this combination or across this cell. So in cell across in a potential difference find out what will be the same potential is across this combination also, right? So for that V is equals to E into RS divided by RS plus R, right? So idu kuda namage formula ide, V is equals to E by RS. That means V divided by RS is I. Namage I ke formula gottide, right? I is equals to E divided by R plus small r, where R is the external resistance. So external resistance ಎರಡು ಇದೆ, ಎರಡು ಕೂಡ series ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ ಇದನ್ನ ಏನಂತ ಬರ್ಕೊಂತೀವಿ RS, right? So again here the current which is flowing is V is equals to I RS. So we need I, that is I is equals to V by RS. So in place of I, we written I divided by RS, that is equals to E divided by RS plus R. So we need voltage E RS, that is equals to RS plus R. So the formula ಯಾವುದು ಬಂತು ಅಂದ್ರೆ here it is, right? So directly we have this formula E into RS divided by RS plus R, right? So all these values we know, that is 11.5 into 50 divided by 50 plus 3, right? So 11.5 into 50 divided by 53. So if we simplify that value, we get 10.84. So V is equals to 10.84 volt. This is the terminal potential difference across A and B. Right? So this is problem on the cell. So ಇಲ್ಲಿ ನೆನಪಿಟ್ಕೊಳ್ಳಬೇಕಾಗಿರೋದು ಯಾವುದು ಅಂದ್ರೆ V is equals to E minus IR and V is equals to ERS divided by RS plus R. So same problem if they given the resistance that is connected in parallel, we need to find RP, that is R1 into R2 divided by R1 plus R2. Now substituting here, ERP divided by RP plus R. So you are going to look the equivalent resistance now first find out now, right? Next, first problem. Two identical cells, either in series, either in series or in parallel, combination gives the same current of 0.5 ampere, 0.5 ampere through external resistance, of 4 ohm. Find EMF and internal resistance. Find EMF and internal resistance of each cell. So two identical cells ಕೊಟ್ಟಿದ್ದಾರೆ. So given condition either it may be in series, so ನಾವು ಅದನ್ನ series ಅಲ್ಲಾದ್ರೂ connect ಮಾಡಬಹುದು ಅಥವಾ parallel ಅಲ್ಲಾದ್ರೂ connect ಮಾಡಬಹುದು. So same current is flowing across the external resistance, that is they given external resistance 4 ohm. So find EMF of a cell and internal resistance of a cell, right? So considering two cells, so identical cells ಆಗಿರೋದ್ರಿಂದ E1 E2 ಬದಲು both we are taken E. So E R and E R. So internal resistance kuda same irutte. So E1 R1 E2 R2 andre two different cells having two different internal resistance, but they given two identical cells, that's why the two cells having the EMF E and two internal resistance having the same resistance, that is R. So this cell combination of the cell is connected to external resistance. So first case ali when we are connected in series, two cells which are connected in series, so external resistance is 4 ohm, right? So current flowing is we taken IS, so this IS value they given 0.5 amperes, right? So next, in the second case, the two cells E comma R and again E comma R which are connected across the external resistance of 4 ohm. So here the current flowing is we taken as IP, right? That is parallel combination means we taken IP. So here also the current flowing is same, that is 0.5 ampere, right? So we need to find E, that is EMF of a cell and internal resistance of a cell. So we know the current through the circuit I is equals to E divided by R plus R, right? So when E is the EMF of a cell and R is the external resistance and small r is the internal resistance. So now we get two cells which are connected in series. So series case also it becomes IS. So series ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ ಎರಡು ಸೆಲ್ ಏನಾಗುತ್ತೆ ನಮಗೆ ಆಡ್ ಆಗುತ್ತೆ, that is 2E, and also the internal resistance kuda enagutte add agutte, that is 2R, right? So IS is equals to 2E divided by external resistance, they given 4 plus 2R, calling this one as equation 1. Right? So the same current formula applying here. So two cells which are in parallel and these two cells are identical, right? So IP, that is equals to E divided by external resistance R plus the internal resistances are connected in parallel. So hence we taken here 1 by R plus 1 by R. That gives what? 2 divided by R. So internal resistance R is equals to R by 2. So here we taken R divided by 2, right? So if we take an LCM here, we get 2E divided by 2R plus small r. So 2R plus R, this 2 goes to the numerator, we get 2E divided by 2R plus R. So external resistance they given 4. So 2E divided by 2 into 4 plus small r, that is equals to 2E divided by 8 plus R, calling this one as second equation, right? So current in series 0.5 ampere, current in parallel 0.5 ampere, that means both currents are same. So from that we can write current IS is equals to IP. So ಎರಡರಲ್ಲೂ current same ಆಗ್ತಿದೆ. So ಎರಡು equation ಏನು ಮಾಡಬಹುದು ನಾವು equate ಮಾಡ್ಕೋಬಹುದು, that is equation 1 is equals to equation 2, that is 2E divided by 4 plus 2R, that is equals to 2E divided by 8 plus R. So 2E get cancels, right? So we can write this one as 4 plus 2R, that is equals to 8 plus R. So R shifts to LHS, 2R minus R, we get, that is 2R minus R, 8 minus 4. So R is equals to 4 ohm. So internal resistance of SL we get, that is 4. Now substitute this R in either second equation or in first equation, we get the EMF of the cell, right? So IS they given 0.5, that is equals to 2E divided by 4 plus 2 into 4, because small r is 4, right? So 0.5 we can write, that is 1 by 2, that is equals to 2E divided by 4 2s are 8 plus 4 12. So 2 1s are 2 6s are 2 1s are 2 3s are, right? So E is equals to 3 volt. So from this we calculated the EMF of SL is 3 volt and internal resistance of SL is 4 ohm, right? So by this we completed problems on all the concepts, right? So from the next class we'll start with the new chapter, right? Thank you.